We're going to start having a look at kinematics and the ideas of displacement, velocity, and acceleration and the way they're linked. Now, displacement is where an object is in relation to a certain point. So we'll just call it where. And generally, when we're looking at specialist maths, we'll have the x-axis and the displacement is a distance to the right or the left of the origin. Velocity, we would know as the speed or something like that, how quickly it's moving. Velocity, however, in the terms of specialist maths, also considers whether it's moving left or right. And so if something's moving to the right, you would expect it to have a positive velocity, and if something's moving to the left, it has a negative velocity. In the same way as with displacement, an object that is to the right of the origin will have a positive displacement, and to the left of the origin will have a negative displacement. Acceleration talks about how much velocity changes. And again, if it's accelerating to the right, you'd expect it to have a positive acceleration, and to the left, you'd expect it to have a negative acceleration. So what that means is if velocity is how much something changes its position, then we could actually use calculus to consider that velocity is the change in position with the change in time, and that's velocity. Likewise, acceleration talks about how much velocity is changing with respect to time, which means that the way velocity changes with respect to time is the acceleration. So now we can use calculus to take the derivative of the displacement with time to find velocity, and same taking the derivative of velocity with time to find acceleration. Now the way that will appear on a graph of displacement here, notice how the x is the vertical axis now on this graph, and time is my explanatory variable, is that my velocity will be the slope of the graph. So if I were to draw a line like this, my velocity is the slope of the graph. I can work that out as well in a straight line case by rise over run. In the same way, if I had a graph of velocity and time, my acceleration would be the slope of that graph as well. Now, if velocity is the derivative of displacement with respect to time, and acceleration is the derivative of velocity with respect to time, then if we integrate or anti-differentiate, we can go back the other way. So therefore, we could consider that velocity was the integral of acceleration with respect to time, or the displacement is the integral of velocity with respect to time. The way that manifests itself on a graph like this is to look at the area under the curve. So if I had a, let's say for argument's sake, a velocity and time graph, and it looked something like this, then my displacement, which is my antiderivative, would be the area under this curve that I've just coloured in light green. So to find that, we would either use integration or we divide this up into sections and add them up. So you can see a straight line velocity time graph allows us to divide this up into a triangle, a rectangle, and another triangle to calculate our displacement. The same relationship exists between acceleration and velocity. So if this was an acceleration time graph, then I would be able to look at the area under the graph to find what the velocity was. This is how displacement, velocity, and acceleration are linked using calculus and integration, or the slope of a line and the area under a graph. If you found this or any of my other videos helpful, please subscribe to my channel or like the video. Thanks.